Hello, everybody. Thank you for attending this, our next webinar in the series for mobile mapping, the Applanix way. My name is Anna Jarvis. I am the Land Product Manager for mobile mapping. I hope to share with all of you today all the information you need to choose the perfect product for your application. Today, we will be reviewing the Applanix product portfolio. So we see here the agenda for this webinar today, which is intended to guide you through various hardware options, software solutions available from Applanix. For newcomers, this will serve as a good overview of the different products offered and help determine the optimal choice for your application needs. And for experienced customers, it will serve to summarize products, highlight new features and developments to improve productivity and accuracy in your mobile mapping workflow. So just a few webinar logistics before we get started. So the presentation will be about 30 minutes. We'll leave some time at the end for a brief Q&A. The webinar will be recorded and all attendees are muted. Questions can be entered, into the question box, and these will be answered either during the Q&A or via a follow-up email for longer answers, let's say. Great, so just getting started, we'll start with a short intro to our profile and mission. So Applanix is wholly owned by Trimble, where Trimble Inc. is a Sunnyvale, California-based hardware, software, and services technology company. So Trimble services global industries in various markets, where Applanix falls into the geospatial category. Applanix was acquired by Trimble in 2003, and being able to harness all the continual hardware developments in Trimble GNSS receivers allows us to inherit all the latest developments in GNSS technology, which is a great advantage. In terms of our mission, at Applanix, we are committed to being the industry leader in all aspects of positioning solutions for mobile mapping. So this includes areas of development, manufacturing, sales and support of positioning solutions for use in any environment. Okay, in terms of Applanix's core competencies, if we are looking at the top image here, we can see that Applanix has a solution for any application, so all vehicle types and all sensors, where a robust position orientation solution is needed. Looking at the bottom, so another core competency is industry-leading GNSS inertial technology, as well as the methods in which these various data are fused together to obtain the optimal output solution. So these next few slides serve to highlight and elaborate a bit on these core competencies and how we strive to solve every challenge faced in mobile mapping. So we all know that mapping and positioning in an urban environment can be challenging, to say the least. With the buildings and trees, we can see how little sky visibility there can be. So to solve this type of challenge, we have a powerful and unique way of integrating the GNSS and inertial data. And this is developed by Applanix, and we call that the Applanix Infusion technology. It enables mobile mapping and positioning to be done efficiently in all types of environments. To elaborate a little bit on that, so some key highlights of the Applanix Infusion technology are discussed here. So through the integration of the inertial GNSS data This is all integrated in a centralized common filter. The inertial data is used to maintain position accuracy during GNSS outages, and then allows for quick recovery after GNSS outages. We do use inertially aided CAR, or IA CAR. This helps to resolve ambiguities robustly and rapidly, basically leading to fast recovery time. A couple more examples here, just to highlight some additional challenges faced in mobile mapping. So in some instances, you may find yourself mapping in remote locations, perhaps with little or no base station availability. So our systems are compatible and ready to use the Trimble Centerpoint RTX correction service, which does allow for centimeter accurate positioning anywhere in the world. As well, we have solutions for corridor mapping. So this is through the purpose-built post-processing software, which is tuned to handle corridor data collections. Great, so here it's also important that I want to share with you that Applanix is the inertial center of excellence for Trimble. So what does that mean for our customers? It means our IMUs are designed and built directly for mapping applications by our dedicated team of experts who are hands-on with designing, manufacturing the IMUs, and this is done both in-house and with partners. So this means that you'll be getting better performance out of our IMUs than would be possible from a similar IMU that was just taken off the shelf. So we carefully evaluate and calibrate our IMUs in-house to obtain the optimal performance at every level. So lastly, for this section, just a highlight of what you get when you choose to go with Applanix. So best in class in terms of hardware options, software solutions, as well as in terms of the employees backing our products. So we have 24/7 support, this is globally, as well as world-class scientists and engineers. To conclude this section, just some feedback from our customers here. So some highlights being greater productivity, smoother workflow, rapid return on investment, and improved process efficiency. Great, so in this next section, we are going to review the mobile mapping portfolio for land in terms of the various hardware, software options that are available. So just as an overview of our entire company, let's say, so Applanix does have several different product lines. The focus of this webinar being on position orientation systems for land vehicles. But just to give a short overview, we do have solutions for direct georeferencing for and flight management systems for airborne mapping. We have precise positioning for unmanned operations, hydrographic and marine applications. We do have a product for indoor mobile mapping, as well as the software to post-process all our data for direct georeferencing, and then what we'll be talking about today, which is position orientation systems for the land vehicles. Great, so in terms of the land portfolio, we do have solutions for every market, from turnkey solutions, which are like the PAWS LV, which is in the top left, to OEM products, which we see here in the top right, those being for resellers and OEM integrators that require flexibility of integration. Looking at the bottom row, we have some software solutions. So for post-processing the trajectory to obtain optimal accuracy. So our products also offer ease of access to correction services with both real-time and post-processed options available, as well as a bore sighting tool for LiDAR users. So we will talk a bit further about all these areas in these next slides. So in this slide, I would like to introduce you to our family of land products for mobile mapping. In terms of our naming designations for our products, so we have the PAWS LV for our standalone system. Our OEM stack is the Trimble AP products. and the post-processing software is POSPAC MMS. So starting with our standalone hardware, being the boxed version, the POS LV is a turnkey position and orientation system for land vehicles, enabling data acquisition to begin right away. So no deep integration required, plug and play. Provides highly accurate navigation solution available in real time, or the data can be logged and used for post-processing. So in these coming slides, we'll look at the various components of this POS LV system. Okay, so looking first at the IMU component. So the IMU is a major component of the system, and the IMU selection will be the key factor in determining the system performance. So this enclosure here houses the gyros, accelerometers, related electronics, which provide the angular rates and accelerations to the navigator. Okay, the next component we are looking at is the POS computer system, or the PCS. We can see here the ruggedized enclosure for the standalone version, as well as the OEM board stack shown here. So the PCS is the computational heart of the system. So it also houses the Trimble receiver, provides power to the antenna and the DMI, has very I/O connectors, and also offers logging from USB or internal logging. As mentioned, the PCS houses one dual antenna GNSS receiver. So this receiver provides the raw GNSS observables from both primary and secondary antennas for dual antenna configurations. So Trimble antennas are high performance survey grade antennas, and they contain advanced technology, so minimizing multipath, robust tracking of low elevation satellites, precise face center accuracy, etc. The antenna we use, are optimized for mobile mapping, where the secondary antenna, that information is used by GAMS for heading aiding. So moving on to GAMS, GAMS is used for, as I mentioned, the dual antenna systems. It does stand for GNSS Azimuth Measurement Subsystem, so GAMS for short. It uses various algorithms to determine the vector between the two antennas. This is helpful to keep the heading from drifting, in particular in low dynamic environments, as well as to obtain improved heading accuracy from, let's say, smaller, less expensive IMUs, and also allows for faster alignment. So that's great. You are ready to start mapping right away. Looking at the next component, we're looking at the DMI, which stands for Distance Measuring Indicator. So the first point here sums it up well. It is used to provide a high accuracy velocity measurements, so including static prefixes, which are provided to the navigator, allowing for improved performance, in particular a benefit during, let's say, GNSS outages. Okay, so this concludes the review of the individual components. So next, we'll look at the real-time versus post-processing scenarios. So for applications that require accurate real-time solution, the POS can accept various formats of real-time corrections, such as RTK, GPS, SBAS, RTX, etc. So in the scenario here, so the PCS, being the computational heart of the system, it receives all the input data. So the input correction data, raw GNSS, field rotation or DMI data, and the raw IMU data, which the real-time navigator processes to output the real-time solution. For applications that require the most accurate post-process results, the real-time data is logged, again in terms of raw IMU data, raw GNSS, DMI data, and the log files are loaded into the POSPAC software with optional correction data or base stations to obtain the most accurate post-process solution. So in this way, the PAWS LV offers both accurate real-time and post-processing options. Okay, so having now reviewed the various components of the PAWS LV product, we have a summary here of the product line. So if we looked at the PAWS LV 200, 400, and 600 series here, they are arranged in order of performance with the 600 at the top end. So some things to note. I know it's a busy slide, so we have included some examples of applications for the different level of product. It's not all inclusive, but to give some examples of common application areas. There is a common PCS across the PAWS LV range, so this allows for ease of upgrade, for example. The choice of IMU defines the solution in terms of the performance. And we do have IMUs available in all levels with no export restrictions. So that's great. DMI is an option on all units, and the systems are available as either a single or a dual antenna variant. Last thing to highlight on this slide is on the left, we have the PAWS LVX, which differs from the PAWS LV series in that it is an all-in-one unit. So it's an entry-level system which contains a GNSS and IMU on a single board, and it's housed in a smaller enclosure. Okay, the OEM product is the board stack version of PAWS LV, standalone product, and is ideal for OEMs as system integrators, where the AP boards are embedded inside, for instance, a larger mobile mapping system that may contain various other sensors, so cameras, scanners, etc. So all functionality of the board stack version is identical to the package variant. So looking at the AP20, AP40, AP60, those are the board stack version of the PAWS LV 200, 400, 600 series that we saw previously. So all same comments apply here in terms of IMU options available with no export restrictions, DMI available for all units, choice of IMU, defining your solution, and etc. On the left here, just like we saw on the previous slide, we have the APX 18. So that is the OEM version of the LVX. And it has, again, the smaller form factor, low cost, it's entry level, and it does have an option, a light option that comes without the RTK. Okay, we'll now take a look at some of the software solutions available. Future webinars will go more in depth into these topics. So just for now, an overview of the software solutions available. Okay, so PAWSPAC MMS 8.7 is the latest release of the Applanix suite of office tools. It is used to post-process the data logged from our GNSS inertial hardware. So PAWSPAC MMS being mobile mapping suite, it processes data from all Applanix products, so PAWS LV, AP, LVX, APX, so all of them. If you happen to have airborne or a marine Applanix system, again, the same software is used to process data from those systems as well. In terms of the workflow, so the data is logged by the PCS in real time, loaded into PAWSPAC along with any base station data if available. PAWSPAC will process the IMU, the DMI, the GNS data, process it all in our centralized filter to produce a high rate SBET, where the SBET is what we refer to as the smooth best estimate of trajectory, or trajectory for short. There are various processing options to choose from within PAWSPAC, and the forward, reverse, smoother processing steps do ensure optimal position orientation accuracy. So the final trajectory can be exported to various available formats, or the user can choose to create their own custom export format. Okay, to give a brief overview of the options you'll find in PAWSPAC, there is a single base processing mode, as well as the Applanix smart base processing mode. It makes use of a network of reference stations, generates optimal observation set to create basically a virtual reference station near the rover location anywhere within the network. So this processing mode would be ideal for survey projects where you're going a large distance. So you can be 70 kilometers plus from the nearest base and still maintain optimal accuracy. We do have PPRTX, which I have a following slide to elaborate on. It is subscription-based, as well as the multi-single base processing mode, which is ideal for long linear projects. So let's say power line corridors, along highways, coastlines, where perhaps a network of base stations is either unavailable or difficult to set up. Okay, as introduced in the previous slide, there is a PPRTX post-processing option. So just a short overview of that processing mode here. It is a post-processed version of Trimble's Centerpoint RTX, which is the real-time correction service. It is a global GNSS correction technology utilizing a dedicated network of stations consisting of over 100 Trimble base stations with worldwide coverage. So the network of base stations are used to compute very accurate ephemeris and atmospheric models along your trajectory. It is a cloud-based service offered as a subscription and accessible globally via internet connection. In terms of the availability of the correction data, let's say after completing your data collection in the field, the RTX correction data will be available within an hour. So you return to the office, download your data. Basically, it's almost ready to roll right away for your use in post-processing your data. In terms of the achievable accuracy, we're looking at about 3 centimeters horizontal and 6 centimeters in the vertical. Okay, last feature that I want to highlight today is, again, this will be a topic of a future webinar that will go a lot more in depth, but it is the LiDAR QC module, which is available in PodPack. So this was developed for system integrators integrated with a LiDAR to ensure the highest level of georeferencing accuracy. So one key point is that no ground control, no targets, etc. are required. So the POS data and the LiDAR data are loaded into POSPack, where the bore site misalignment angles are computed automatically. After this, after the calibration, either the options are last files can be generated from POSPack, or an updated trajectory file can be exported with the bore sites applied, or alternatively, the calibrated bore site misalignment angles are ready to be applied in, let's say, any user's third-party software if they like. A common question that we get is the input LiDAR data format. So at this time, we accept a generic binary format of doubles, as well as the native Velodyne VLP16 file format. Okay, to wrap up our webinar today, we will look at a few of the markets where our mobile mapping products are commonly used to solve just various mapping and positioning needs. So here the POS LV can be found in the automotive industry, and it is most often used for testing and ground truthing. Testing the performance, for example, of a vehicle's driver safety features, self-driving capabilities, lane keeping, etc. Is also often used to obtain information on vehicle handling and performance. Another common application is infrastructure management. So we see here a crew doing some road maintenance, where the POS LV can be used to monitor pavement conditions for roads, as well as runways, tag any issues that require maintenance to be scheduled for, etc. Okay, for rail applications, so we have been working in the rail industry since the early 90s when we joined into a tight cooperation with Placer for the development of a track geometry solution where the POS LV is geared towards rail applications. Common areas for application in rail are corridor mapping. So for example, creating and maintaining maps of vegetation growth, surrounding features, as well as track geometry, where the tracks are inspected to assess, for example, if any repairs are required. Okay, in terms of fleet management, so the Applanix POS-LV enables real-time localization of each asset moving through tunnels, rail yards, under canopy, including GNSS denied areas, thus enabling optimal management of the fleet. So it offers required information for example, inventory management, route optimization, etc. Okay, so lastly, we come to HD mapping and 3D city models. So we can find the POS-LV products being used for rapid data collection of imagery or LiDAR data from a mobile mapping vehicle for purposes such as 3D city modeling, road furniture inventory, consumer mapping products, engineering grade laser scanning, etc. So in summary, we have developed and continue to develop all the technical solutions for different markets to make our customers successful. So in conclusion, what is the Applanix advantage? So just some key highlights here. Applanix has pioneered the commercial use of GNSS inertial navigation for land mobile mapping pretty much since 1995. We do have over 25 years in R&D for robust positioning in all conditions. We have a large staff on hand, so over 120 personnel with proven track record. We do have worldwide global support, and we are owned and backed by Trimble. Okay, to just highlight what's coming up next. So in the next of our series of webinars, we'll take a deeper dive into POSPAC, so talk more about those different processing modes that I gave an overview on. And then followed by a detailed look at the LiDAR QC tools for the bore site calibration. So stay tuned for these exciting webinars coming up next. So if you have any lingering questions, feel free to enter them in the box at this time. And in the meantime, I would like also to share the slide with you. The final slide here, just summarizing the large team of experts that are backing our products. We hope to see everyone soon once travel and conferences basically start to return to in-person. I'll just wait for the questions here. Okay, so I see the question here. Thank you. So asking, does the software POSPAC come with purchase of any of the hardware? Okay, so these are purchased separately. So you can purchase either the hardware and add POSPAC on later if you decide you need post-processing capabilities. So they are split apart or bought at the same time. It's entirely up to you. And it looks like I have another one here. It's the POS-LVX replacing the LV125. Okay, so this is a experienced user. Yes, so we do have the LV125. It still is a product that we have. At the moment, we're promoting moving towards POS-LVX and some other products soon to be released. But there is still the option of LV125. If you're a long user of that product, you can still purchase it for sure. Correction. Okay, looks like I got one last question here. So the correction of smart base, is it provided by Trimble? Okay, so it is inherited from Trimble. So Trimble has a real-time VRS capability, which takes in corrections from a network of bases in real time. So this is the post-processed implementation of the Trimble VRS. So thank you for that. Okay, so, oh, sorry, I have one more. Any cars? Okay. Follow-up question here, are any chorus correction data used? Yes, so sorry, to elaborate on the smart base, it does make use of the CORS base stations. So we have a database in POSPAC that lists, all the core stations currently available, and actually a user can supplement the smart base network. So if the core's bases don't fully encapsulate your survey area, you can add your own base station as part of the generation of the virtual base. So whatever bases are available surrounding your area can be used for the smart base processing. Okay, wonderful. So I think that brings us to a close here. I want to thank everyone for attending today and for their interest in the Applanix products. Please do feel free to reach out to me directly or to any of our team members, of course, not only today, but also at any time in the future. Great, thank you.